Hello students, today we are going to start a new chapter, that is current electricity. Previously in chapter number 1 and chapter number 2, that is electrostatic 1 and electrostatic 2, whatever we have studied, there the charge is at rest. But in current electricity, we are going to see that the charge is not at rest and the charge is keep moving in the circuit, right? So let's start this current electricity chapter. So in current electricity, the charge is at motion. The charge is at motion. But in electrostatic case, we have seen that the charge is at rest. Second thing is that in current electricity, the electric field inside conductor is not zero. Remember, in electrostatic case, we have seen that the electric field inside the conductor is zero. Basically, if I take this is a conductor, this is talking about electrostatic case. If you apply a external electric field, this is a external electric field you have applied. If you apply external electric field, then the free electron will be moved along this direction and get accumulated here. Due to this accumulation of negative charge, this side will be, there will be a positive charge induced, right? And inside the conductor there is a external electric field, and due to the induced charge there will be a induced electric field. Whenever this electrostatic condition will come, there the external electric field magnitude will be same as the induced electric field magnitude but in opposite direction. So if you see, the net electric field inside will be 0. The net electric field inside the conductor will be 0. But in current electricity, these charges will be not accumulated on that surface. These charges will be keep moving in the circuit. What is a circuit? We are going to see. But you remember, in current electricity, the field inside the conductor will not be 0. Because this charge will move, due to this charge will move, there will be no net induced electric field. Whatever electric field you will be applied, that electric field will be existing in the conductor, right? Clear? Now we will going to see how you define a current. Current is basically defined as rate of flow of charge, right? So let's take this is a conductor. Let's take this is a conductor and choose a cross sectional area here, and that area is A, let's say, right? Through this area A, delta Q amount of charge is flowing in delta T time. Then you define current crossing through this surface area I equal to delta Q by delta T. You know, if the time interval will be very big, then you will tell that this is average current is flowing. This is delta Q by delta T. If time interval will be very small, then you will tell that instantaneous current will flowing, or current at any instant you are finding out, that is I equal to dq by dt. That thing you know, like instantaneous velocity, average velocity, similarly instantaneous current and instantaneous current and average current, right? So unit of current is coulomb per second, or this is ampere. Similarly, dimension of the current can be written as A or I, right? So you know that current basically is a scalar quantity. This is a scalar quantity, but it has direction. It has direction. Current is a scalar quantity, but it has direction because it does not obey the vector algebra, right? Now talk about this direction of the current, because current is defined as flow of charge. Now we will define this direction of current by flow of charge. If you take negative charge, what will going to happen? If you take positive charge, what is going to happen? Okay. If charge are positive, the current in the direction of the motion of the charge, right? So you take positive charge, let's say this is a conductor and the positive charge is moving along this direction. If the charge is moving along this direction, then the current will be along this direction, same direction. Motion of positive charge or direction of motion of positive charge same as the direction of the current or current flow in this direction. If you take negative charge, here if you take negative charge, if the negative charge is flowing along this direction, the current direction will be opposite to the direction of motion of the negative charge. Negative charge means we are talking about electron, right? Basically, if the electron is moving along this direction, the current will be moving opposite direction of motion of the electron. Clear? Let's do one problem. If a current of 5 ampere flow through the conductor, the number of electrons per second will, right? So you know that I equal to delta Q by delta T. Clear? So delta Q is what? Delta Q is total number of charge into charge of electron, right? This is total charge. Delta Q is total charge. So I can write N into E. Here they have taken electron, so I am writing N into E. Divided by delta T, they have given 1 second. Per second they have given 1 second. And I can write N equal to I by E. So I is your 5 ampere divided by E is your, I can write how much? 1.6 into 10 to the power minus 19 coulomb. So this can be written 50 divided by 16 into 10 to the power 19. So it will be 3.10 will be, so it will be 20. This will be 1, right? And 1, 2. Yeah. So this will be 3.12 into 10 to the power 19. So the option number 2 will be. So this much number of electron has to flow per second to give 5 ampere current. Clear? Now we'll see another term that is called current density. So current density is a vector quantity, and you define current density, the current per unit area, and that area should be perpendicular to the direction of current, or you can say that current per unit perpendicular area, right? So they are written that current density is defined as current per unit perpendicular cross sectional area, and that area is perpendicular to the current at that point, right? So we'll see what it is saying, that perpendicular area and all this thing we'll see in detail. So J can be written as I by A, and the direction of the J is n cap. It is in the direction of current. That thing they have written. Direction of current density is same as direction of the current, right? Or you can write I equal to J dot A, dot product between J and A. If J is not a constant quantity, you can write I equal to di integration, and basically integration of J dot dA, right? So this is whenever you have to apply this formula, whenever J is not constant. Here J is not constant, then you have to apply this formula. Now see here, I take this conductor. Now you will understand what perpendicular area, why it is perpendicular area, you will get to know now. So let's talk about this is a conductor, and here the current is flowing along this direction, J also along this direction, because J direction is same as current, and this is the cross sectional area A. You know that direction of area will be here along this direction. Direction of area will be along this direction, right? The area direction will be along this direction. So if someone will ask what will be the current here, you will tell that I equal to J dot A, and you will say that this is J A cos of 0 degree, because density is along this direction, the area also along this direction. The current will be J A cos 0 degree, and it will be J A. Clear? Similarly, if I take a rectangle here, if I take a rectangle here, rectangular in 3D I have taken, right? And here I am telling that let's say the current is flowing along this direction. Current is flowing along this direction. Clear? Now this is the area here I am talking about, this cross sectional area, and this area is A. Here also you will tell that J equal to, or you can say that I equal to, you will say that I equal to J dot A, and this is basically area, means along this direction area will be, and the current density will be along this direction, J A cos of theta, and theta will be here 0 degree, so it will be cos of 0 degree, you will write J A. Now you see here, I take a conductor like this. This is the conductor now. This is the conductor I took now, right? And in that conductor, this is that cross sectional area. You know that this area will be perpendicular. So this is your area. Area direction will be perpendicular to the surface, right? This will be area. And that I is along this direction, J also along this direction, because I and J are in same direction. So if you see here, this J is making an angle that is theta to the area, direction of area. So in this case, if I write the current I equal to J dot A, it is coming as J A cos of theta. Clear? J A cos of theta. So J basically can be written as I by A cos of theta. Clear? Now you see here, this area I am drawing here, this is that area we are talking about, right? This is this area, and this direction I am taking as this direction, and one direction I am taking along this direction. So if this is making a theta here, perpendicular to this one, this angle is theta, so this angle also theta. So obviously this angle will be going to 90 minus theta, right? This angle going to be 90 minus theta. So I am just removing everything, I am just putting here 90 minus theta, right? I am not writing, this will be clumsy, right? Otherwise everything will be here. So I am directly writing this will be here 90 minus theta. So if this is 90 minus theta, then you can say that there is a component of area along this direction that will simply A sin theta, and there will be a component along this direction that will be basically your A cos of theta. So A cos of theta is along this. This is the area. You just imagine this is the area initially. A cos theta is along this direction and A sin theta is along this direction. So here if you see, this is coming A cos theta and current direction is along this direction. Area is this one. area is along this one, this direction. So A cos theta is along this direction and current is like this. You are getting right? Current is like this and this is A cos theta. So this is the perpendicular area to that current, right? So I can write here I by A perpendicular, right? So A cos theta is perpendicular to the direction of the current. That's why it is taken like this. That's why the definition is saying that current density is defined as current per unit area and that area is perpendicular to the direction of that current. Here it is clear, right? Okay. Now you can see that unit of the current density, this is basically current per unit area, so it will be ampere per meter square. That unit will be ampere per meter square. Clear? Now let's see Ohm's law, right? So Ohm's law basically saying that the potential difference between the two ends of a conductor is directly proportional to the current flowing through that conductor. So let's take a conductor. Let's take this is a conductor. This is a conductor. And this side is V1 and this side is V2. And I am telling that V1 is greater than V2. V1 is the higher potential, V2 is the lower potential. So V1 is greater than V2, that means the current will always flow from V1 to V2. Why it is so? Because previously we have seen that direction of current is same as direction of the motion of positive charge, and you know that the positive charge move from higher potential to lower potential. In electric field also we have studied this thing. So the current direction will be along this direction because this direction is the motion of the positive charge. Clear? So I can say that difference between the potential at two ends of the conductor, that is V1 minus V2, is proportional to the current flowing through that conductor. So this is, I can write delta V is proportional to I. So delta V is equal to Ri. R is what? R is resistance of the conductor. R is a proportionality constant and it is the resistance of the conductor, right? Or resistance of the wire, whatever, right? So we'll talk about the resistance now. Resistance equal to, you can write delta V by I. Delta V is the unit of volt, so you can write this is volt per ampere. So unit of resistance is, this is the unit of resistance. Unit of resistance. Unit of resistance also can be written as volt per ampere or ohm. This is ohm. So ohm is basically the SI unit of resistance. This is the SI unit of resistance. Clear? Ohm is the SI unit of resistance. The symbol we put for ohm is like this. For resistance we put ohm is like this, ohm. This is omega, right? This you remember, this is omega and symbol we put like this. Let's say R equal to resistance equal to 5 ohm. I will write 5 into this omega. 5, like say I will tell resistance equal to, I will tell that 5 ohm. Instead of write this, I will write 5 ohm. Clear? By symbol wise it's given like this. Okay. Now if someone will ask, can you write down the dimension? So dimension is, you can derive from here. We'll say the volt per ampere. Volt can be written as joule per coulomb divided by ampere, right? And this will be basically your Joule is what? M1 L2 T minus 2 divided by Coulomb into ampere. Coulomb can be written as I into T, right? Into ampere is your I. This will be M1 L2 T minus 3 I minus 2. This is the dimension of the resistance. Clear? Now come back to this relation. Delta V equal to Ri. So this relation is telling that delta V equal to Ri. Delta V equal to Ri. So R can be written as delta V by I. Clear? So if I draw a graph between delta V and I current, then the slope will be given by this resistance, because this is Y, this is X, the slope will give the resistance. So it will be like this, and this theta if I take, the tan theta here will be your slope, and that slope is your resistance, right? Got it? This is like equation, right? This is y equal to m into x. Y you can take delta V, and x is your current, and m is your r, that is your slope, y equal to mx, and it will cross through that origin, right? This will be the case. So if I ask one question to you, this is the graph between delta V and your I, and two graphs are given. One is your, this is your R1 and this one is R2 they have given. And option they have given that R1 is greater than R2. Option 2 they have given R1 is less than R2. Option 3 they have given R1 is equal to R2. So which one will be correct? So you will say that here for R1, this one I am taking as theta 1. For R2 I am taking as theta 2. Right? So you will tell that theta 1 is greater than theta 2, right? Theta 1 is greater than theta 2. I am solving here. So theta 1 is greater than theta 2. Clear? If theta 1 is greater than theta 2, tan theta 1 is greater than tan theta 2. Right? This is solution I am doing. So if tan theta 1 is greater than tan theta 2, so we will say that tan theta 1 is equal to your R1 is greater than R2. So this option will be your correct. Clear? So this question they can ask like this. Okay. Now we have seen this conductor like this. This is a conductor, and this one we are talking about V1, this is V2, and the current is along this direction if V1 is greater than V2. Clear? And it has a resistance R. So I can show this conductor in this way also. This is the resistance. I will put the resistance is like this, and this is one end, that is V1, this is other end V2. So I can do like this. Clear? So let's do some problem here. So question number 1. This is a conductor having resistance, let's say 2 ohm. This side is your 10 volt and this side is your 5 volt. Right? Now they are asking find out the current here. So find current. So you will say that I equal to delta V by R. This relation you know, V equal to IR or I equal to delta V by R. So delta V is equal to 10 minus 5 divided by 2. this will be 5 by 2, this will be 2.5 ampere, correct, 2.5 ampere. Now second question, let's say this they have given 10 volt, again 10 volt, and this is the resistance they put, again 2 ohm, and now this side they have given this voltage is minus 5 volt. Now they are asking find current through the circuit, how much current, and you can say here the current direction will be how much, in which direction, current will be flowing along this direction, here also the current will be along this direction. So you will tell that I equal to delta V by R. So delta V means 10 minus minus of 5 divided by your 2 ohm is equal to your 15 by 2, that is 7.5 ampere, right. This will be your current flowing through that resistor, right. Now let's see question number 3. Okay, so here what it is saying that, let's talk about, this is again I am taking 10 volt, this side I am taking as 4 volt, and the current here it is flowing I equal to 2 ampere. You have to find out the resistance value. So you will say that resistance equal to delta V by I, right. So delta V is be how much, 10 minus 4 divided I equal to 2. So this will be 6 by 2, that will be 3 ohm, right, 3 ohm resistance of the wire, right, and the current direction will be along this direction. So question number 4, let's say this side it is minus 5 volt and this side it is minus 15 volt, right. Now you have to tell that which direction the current is flowing, and let's take this resistance they have given 2 ohm. Which direction the current will flow, again you have to tell that how much current is flowing, right. So I you have to find out. So obviously you will say that minus 5 volt is a higher potential than minus 15 volt. The current will be flowing along this direction, clear, and you will say that how much current is flowing, I equal to delta V by R. Delta V will be how much, minus 5 minus minus of 15 divided by your resistance is 2. So it will be minus 5 plus 15 divided by 2. This will be 10 divided by 2. This will be 5 ampere. Clear? 5 ampere current will flow from minus 5 volt to minus 15 volt, because minus 5 volt is a higher voltage than minus 15 volt. Clear? Like that you can find out. Okay. Now this resistance is directly proportional to the length of the conductor. We'll see, we'll derive a formula for the resistance. You will see that this is directly proportional to L, because you know in 10th class this formula, all these things, that's why I am introducing here. So resistance is proportional to the length of the conductor, right? And resistance is directly proportional to 1 by cross sectional area, or inversely proportional to the cross sectional area. And so you can write resistance is proportional to L by A if you combine these two equations. Resistance is proportional to L, resistance is proportional to 1 by A. So this will be resistance equal to, resistance is proportional to L by A. Clear? And here if you write resistance equal to rho L by A, rho is called your resistivity of the material or resistivity of the conductor, right? Or it has another name that is called specific resistance. Sometimes in question they ask that specific resistance, without giving resistivity they will give the specific resistance. So you have to keep in your mind that its other name is specific resistance also, right? So it's R equal to rho L by A, right? And you just remember rho is your resistivity or specific resistivity. In detail we will talk about resistivity, right? Unit of resistivity, if you see, this will be ohm into meter, because L by A is dimension of meter inverse, so it will multiply here R into L, right? So it will be ohm into meter, and its dimension is, for resistance we have seen, right, M1, L2, T minus 3, A minus 2 we have seen for resistance. You have to multiply a length here. So it will be M1, L3, T minus 3, A minus 2, or I minus 2 also you can write. This can be written I minus 2 also. Clear? So you have to remember here that resistivity depends on the material of the conductor, but not on dimension. You see, resistance, if I write, it depends on the length of the conductor and area of the conductor also. But resistivity does not depend upon the length, area of the conductor. That means it does not depend upon the dimension of the conductor. That means if you take a iron rod, if you take a iron sheet, if you take a iron rectangle, whatever you will take, the resistivity will same for that material. So what it is saying, that resistivity same for iron rod and iron sheet, right? For iron sheet and iron rod, or whatever you will take, for iron this resistivity will be same. If you take resistivity will be different for iron and let's say gold. Resistivity will, if you take a wire of copper, or if you take a wire of gold and you take a wire of iron, gold and iron will give you different resistivity. If you make the dimension also same, let's say you take a rectangle of gold, you take a rectangle of rectangular area of the iron also. So sheet, basically metal sheet, both will give you different resistivity even if their dimension are same. Clear? Resistivity is depends on the materials, not the dimension, right? And resistivity also depending on the temperature. We are going to see that resistivity, if you increase the temperature, if you increase the temperature, the resistivity also increases. This is I am talking for conductor, right? And if you decrease the temperature, the resistivity will decrease. Why it is going to happen, we will see again, right? We will derive the formula and there we will talk about why it is going to happen. This is true for conductors. But semiconductor is different thing. In semiconductor we will see that this will be opposite of this thing, right? You remember that for conductor, temperature increases, the resistivity increases, temperature decreases, the resistivity will be decreasing, correct? And this relation is very important, R equal to rho L by A. Clear? Now we will see stretching of wire, right? Stretching of wire. Let's, this is a wire of length L and area A. Now you stretch it. If you stretch it, what will happen? Its area will decrease and length will increase, right? This is A dash and this length is L dash. Clear? You can take L dash, capital L dash, right? So in this case, what is happening here? Because you are taking the same material, the rho is constant. And second thing is volume also constant. Why volume is constant? If you take a rod and you stretch it, the volume is not going to change, right? Because the length is increasing, area is decreasing. Whatever may be happen, or if you squeeze it also, the volume is not going to change, right? The volume is also constant. This will be volume also constant. So now if you see, what will be the resistance here? Resistance equal to rho L by A. What will be the resistance here? R dash equal to rho L dash divided by A dash. Clear? What I will do? I will multiply L on numerator and denominator. This will be rho L square divided by A into L. This will give you rho L square by volume. Here I multiply L dash on numerator and denominator. This is rho L dash square divided by A dash into L dash. That will give you rho L dash square by volume. Right? So rho by volume, resistivity by volume and resistivity by volume is same. So if you see these two equation, I can write here R by L square is equal to R dash by L dash square, right? This I can write. So you can say here that from these two equation, resistance is directly proportional to L square, right? Resistance of a wire is directly proportional to length square. That means if you stretch it, the resistance will increase in terms of L square. Correct? We will do some problem, this will be clear, right? So this will be here, R is proportional to L square if there is a stretching case will come. If you cut the wire, let's say this is your conductor or wire, this length is L, and you cut it to two piece. You cut it to two piece. Then what will happen here? Here you will get this is L by 2 and this is L by 2, right? You cut this one, right? Here the area is A, the area is not going to change here, but in stretching case the area is going to change, but in cutting case the area is not going to change. So here you can say that resistance equal to rho L by A. Here new resistance will be R dash equal to rho L by 2 divided by A. So that can be written as R divided by 2. Similarly, this R dash can be written as R by 2. So similarly, if you see here, if the length is decreasing, the resistance of the conductor also decreasing. So if I ask you a question here, so if L length conductor, or I will say that this is the conductor of L length, and you cut it to 3 pieces or 2 pieces. Now one piece is your L by 3 length and another piece is your 2L by 3, right? Now after cutting, just find out the resistance of these two here. This is find out the resistance of 2 here. So the resistance of 2 here you can find out. Here it is L by 3. So obviously this resistance will be R by 3. If the total resistance of wire is R, and this will be R by 3, and this will be 2R by 3. R is the resistance of this wire. After dividing you will get this two resistance, and one resistance will be R by 3 and another will be 2R by 3. If it is cutting, the conductor is cutting or the wire is cutted, so the resistance will be proportional to the your length of the conductor, right? Clear? So another thing I want to say here, so let's take one conductor here. This is the conductor, right? This is the conductor, and here this is the area A, right? This side also area A. This length is your L, right? So here the resistance is written as rho L by A. Clear? So if I take a 3D shape like this, right? So if the current is flowing along this direction, right? So now the resistivity, if someone will ask, the resistance, if someone will ask, you will tell the resistance equal to rho L. You have to take this length, right? This side length you have to take. Rho L divided by A will be taking this area, this cross sectional area you have to take. Clear? Now I will take another example. Let's say this is one conductor. Here I am doing it. So this is one, and concentric cylinders, right? And here it is conductor. Inside it is hollow, right? So this radius is small r1 and the outer cylinder has radius of r2, and the current is flowing along this direction. The current is flowing along this direction. If someone will ask how will write down the resistance, resistance equal to rho L. L is the length of the conductor, or this is the length of the conductor here. This is the length of the conductor, and divided by area. Area you have to choose this area. If you calculate this area will be coming pi r2 square minus pi r1 square, right? You see here, this is pi r2 square divided by pi r1 square, right? This you can write the resistance here. Inside it is hollow, right? This is hollow here. Inner cylinder is hollow inside, but outer cylinder is, you can take that, here it is conductor equivalent, right? Clear? This will be the resistance rho L by area will be how much? And here the current is flowing, here it is the current is flowing, right? So the current will be, so resistance will be rho L by area. Area will be pi r2 square, that bigger cylinder or outer cylinder, and inner cylinder is r1. Oh, we have taken small r1, we will take capital. This will be your capital R1, and outside this is your capital R2. This is the radius of the cylinder, right? Okay, we talk about resistivity now and stretching of wire. Now we will do some problem to understand this whatever we will study clearly. So if the length of the wire is doubled and its area of cross section is decreased to half, so what they are telling, I am doing solution here. So length of the wire is doubled, length is going to tell 2L, right? And the area of cross section is decreased to half, so area is going to be A by 2. Then the resistance, first find out for this case. So we will tell that here resistance equal to rho L by A. right? This is the same wire, you are just stretching it, right? So the resistivity is not going to change, or specific resistance is not going to change. Rho will be same for both case, right? And for this case, your R dash will be rho into 2L divided by A by 2. This can be written as rho, 4 will go outside, L by A. This will be 4 into R. So you can say that the new resistance will increase 4 times. This will be option number 1 will be correct. Clear? Okay. Now see second question. If a wire of resistance is R is stretched to double of its length, then new resistance, stretching question come. So initially the resistance is R, finally they are asking R dash. So you know that we have talked about if stretching is happening, resistance is proportional to length square, right? So you will say that resistance is stretched to doubled. So here it is L, here it is 2L. So you can say that R dash is proportional to 2L square, right? So you can say that it is proportional to 4L square, right? And you know that this resistance will be proportional to L square. So I can write R dash is equal to 4 into R. Clear? R is proportional to L square, so it will be 4 into R. So it will be increases 4 times. Clear? That same concept I have used, this stretching. If you see here, this stretching I have used. Same thing. You write for this both the wire, you will get the same answer. Right? 4R. Now, if we double both the length and cross-sectional area of the wire, then its resistance will be. So, what it is telling? Double both length and cross-sectional area. So, L is going to 2L, A is going to 2A, right? A is going to 2A. Now, for this case, the resistance will be rho L by A. For this case, the resistance will be R dash equal to rho 2L divided by 2A. That is rho L by A. So this is equal to R. So it will be remain same, right? This will be option number A is correct. Okay. Now next question. 2 wires made up of same material. Same material means what? Resistivity is same. Have their length are in the ratio of 1:2. So here they are telling L1 divided by L2 is equal to 1/2. And their masses in the ratio, they have given the masses here. So if you see here, masses they have given M1 divided by M2 is your 3/16. The ratio of resistance they are asking. So they are asking R1 divided by R2 will be how much? Right? First write down R1. What will be R1? R1 equal to rho L1 divided by A1. This can be written as rho L1 square divided by volume 1. Right? And I know that mass per unit volume is your density, right? Here 2 wires made up of same material, that means resistivity is same and density also same, right? Same material means density also same. So here I can write rho L1 square. In place of volume I can write mass, or mass in place of mass I can write simply M1. This is M1 and this is multiplied by the density. This is the density, right? Similarly for R2 I can write rho L2 square. Here I am following this one. Then this density, because density is same for both, divided by M2. Clear? Now come here. So R1 is to R2 is equal to, now you see here, this will be R1 can be written rho L1 square divided by M1 into, divided by R2 means M2 will go up, so this will be M2 divided by rho L2 square, and density will get cancel out, right? So I am not writing. So rho get cancel out here, or you can, if you are trying to write down density divided by density, you can write, so it will get cancelled out, rho get cancel out, and you will see that this is coming L1 by L2 whole square into M2 by M1, this is coming, right? So here it will be L1 by L2, they have given half, so 1 by 2 whole square into M2 by M1, this will be 16 by 3, so this will be 4, this will be 4 and this will be cancel out, so it will be 1 by 4 into 16 by 3, this will be 4 by 3, the ratio will be 4 by 3. So option number D will be her correct option, correct? Now next question. Okay, this question is done, right? Now so for next question, two ears have their length in the ratio of 1:3. So L1 divided by L2 they have given 1 by 3 and diameter in the ratio of 2:3. So D1 by D2 is given as 2 by 3. So if diameter is given D1 by D2, so I can simply write R1 by R2 will be same. Because diameter is 2 into R1, 2 into R2, this 2 get cancelled, this will be R1 by R2, okay. And their materials have specific resistances. See here, they have, without giving resistivity, they have given specific resistance. So specific resistance they have given. So this R we can take small, smaller, otherwise it will be messed with the resistance, small R1, small R2, right? Materials have specific resistance in the ratio of 2:1, rho 1 by rho 2 equal to 2 by 1. Then the ratio of their resistance, they are asking the resistance, all this data we have. So R1 by R2 they are asking. So R1 by R2, how I will write? R1 by R2, R1 can be written as rho 1 L1 divided by A1 divided by rho 2 L2 divided by A2. So this will be simply rho 1 by rho 2 into L1 by L2 into, this will be your A2 divided by A1. So rho 1 by rho 2 is how much? 2 by 1 into L1 by L2 is your 1 by 3 into A2 by A1. A2 can be written as, so if you see here A2 by A1, if I write A2 by A1, this will be pi R2 square, this will be pi R1 square, right? Pi get cancel out, this will be R2 square by R1 square. So I can write here, this will be simply R2 by R1 whole square. So I know R1 by R2 2 by 3, so R2 by R1 will be 3 by 2 whole square. So you see here, this will be 1 3 get cancel out this one, 1 2 get cancel out with this one. So it is coming 3 by 2 simply, right? So 3 by 2, or you can say that this is 3:2. So if you see here, option number C will be your correct option. Clear? Now next question, a wire of stretched 50%, a wire of length L. So let's take length L, stretch 50%, right? Calculate the percentage change in resistance. So percentage change in resistance formula you know, right? Percentage change in resistance is R final minus R initial divided by R initial into 100, like percentage change. But we also use this formula previously for other cases, not for resistance cases. Percentage change in velocity or all these things, we have calculated this type of formula, right? Percentage change, right? So L is stretching 50%. So if you are stretching 50% means what? You are increasing L by 2. 50% means what? L by 2, right? So it will be going to L plus L by 2. So it will be 3L by 2 you are doing, right? This will be final length, this is initial. If stretching is happening, you know that R is proportional to L square, right? So I can say that R initial is proportional to L square and R final will be proportional to 3L by 2 whole square, right? Because R is proportional to L square. So percentage change in resistance can be written as R final, this will be 3L by 2 whole square minus R initial will be L square divided by R initial will be L square. So whatever proportionality constant will get cancel out, right? Because you are dividing also R initial into 100, right? So it will be 9 by 2 minus 1, L square everywhere get cancel out into 100, right? This will be 9 minus 2 will be here, how much it is coming? This will be coming here 9 by 4, no, not 9 by 2, this will be 9 by 4, sorry, this will be your L square, so this will be your 9 by 4 minus 1 into 100, so this will be 9 by 4 will be 5 divided by 4 into 100, so this will be 25, this will be 25, this will be 125 percentage, right? So it will be option number C will be correct. So if the length will be increased 50 percentage, the resistance will increase 125 percentage. Clear? If a wire of 1 ohm, done, right? This next question we are going to see. If a wire of 1 ohm has length of 1 meter and stretched till its length increase by 25 percentage, right? The percentage change in the resistance, same formula you have to follow here. They have given only here 1 meter, they have given L, here they have given 1 meter, right? So here you going to wire of length L, right? Okay. So here it is given 1 meter, so it's 1 meter to it will go which value? It will be going to 25 percentage increasing, that means 1 plus 1 by 4, that will be your 5 by 4, right? 5 by 4. They are 50 percentage increasing, that's why I add L by 2. Here 25 percentage increasing, that's why I add 1 by 4. This will be 5 by 4. This will be final length 5 by 5 meter. So percentage change in the resistance will be your R final minus R initial. R final can be written as proportional to 5 by 4 whole square minus 1 square divided by 1 square. Following this formula only, right? This will be 25 into 100, right? Here you have to put into 100 because you are calculating percentage, right? So it will be 25 by 4 my 25 by 16, right? This will be 25 by 16 into 25 by 16 minus 1 into 100. Yeah, this is correct. So this is 25 minus 16 will be 9 divided by 16 into 100. So you can calculate this one is 90 divided by 16 into 10. So it will be 90. So it will be 5. Then it will come 10, 100. So if this is 100, then you will put 6, right? So 6, right? It will be around this one. So, and this will be 5.6, right? So it will be 5. So it will be 56 percentage will come, right? So option number C will be correct, right? So this will 9 by 16. This will be 16. 5, 80, 10 will be there, then point you put, then 100, this will be, yeah, this will be correct, around 56 percentage it is coming. Clear? Now there is another term that is called conductivity, right? So conductivity is reciprocal of your resistivity. Conductivity is basically reciprocal of your resistivity. This is defined as like this. If this is reciprocal of resistivity, the unit will be inverse of that resistivity. So this will be resistivity ohm meter, this will be ohm inverse meter inverse, or ohm inverse can be written as MHO, right? And meter inverse or Siemens meter inverse. And the dimension for resistivity you can write m minus 1 l minus 3 t3 a2, because resistivity dimension you remember this will be m1 l3 t minus 3 a minus 2, right? So you just reverse it, this will be the dimension of conductivity, right? This is conductivity sigma, right? Then there is another term that is called conductance. Conductance is defined as 1 by R, or reciprocal of the resistance. And reciprocal of resistance, you know, this unit is ampere per volt. That is for resistance, if you remember resistance, we know that volt per ampere. Here it is ampere per volt, or ohm inverse, or MHO, or Siemens. This is the unit of the conductance, and you easily find out, right? You easily find out the unit of this conductance, right? Because you know the dimension of the conductance, because you know the dimension of the resistance, right? Or if you want to write down, so dimension of resistance, you know that this will be m1 l2 t minus 3 a minus 2, this thing you know. So its dimension will be, you can write this is m minus 1 l minus 2 t3 a2, right? If you see that resistance dimension, and you will get this one, right? Clear? This will be the dimension of the conductance, right? Okay. Now we are going to see another form of Ohm's law, and this is very important formula. This formula is very important, J equal to sigma E, and we will derive it now. So let's take this is a conductor. This is the conductor, and this side is potential is V1, and this side is potential is V2, and obviously we are taking V1 is greater than V2, right? And I can write J equal to, I am writing the magnitude here, J equal to I by A. This is the area A, and this is the direction of the current, right? I by A. So current can be written as, now you get to know that current can be written as delta V by R divided by A. So delta V divided by R A. So in electrostatic case, we know that we can write delta V equal to E into L. E is your what? Electric field, if you remember, right? So here I can write E into L divided by RA. Potential difference is equal to electric field into the length, right? So this will be EL by R. So obviously I am writing in scalar form, not the vector form. So J can be written as now EL by RA, EL by RA, or this can be written as E divided by RA by L. So E divided by RA by L. Now we have seen this is your resistivity or specific resistance, or inverse of resistivity is called your conductivity, sigma into E, right? So if I put the direction, J direction is along the direction of the current, is equal to sigma. Sigma is not a vector quantity, it is a scalar quantity, into E. E is the vector. So you see here V1 is greater than V2, that means electric field direction also along this direction. I direction if this direction, the J direction also same direction. So J and E are in the same direction. So J equal to sigma into E we have proved here, right? J equal to sigma into E. E is the electric field, sigma is the conductivity, right, and J equal to your current density. And this is very important formula, and the derivation is very important for the exam, right? For the theory exam it's very important, and they can ask many problem with this formula. J equal to sigma E. You just remember that direction of current is the same direction of the current density, and the direction of the electric field also same, right? So E is along the direction of the current density. Clear? Now I am going to do some problem here. A copper wire of length L, so length 10 centimeter, so length they have given 10 meter, and radius also they have given, small r we will take, small r we can take, that is 10 to the power minus 2 pi root over, right, meter. This one is just remove. Radius is this much, has electrical resistance of 10 ohm. So R they have given 10 ohm. The current density in the wire, they are asking current density. If an electric field strength, they also given E equal to 10. All are in SI unit. If you see, this is in meter, this is in meter, this is in ohm, this is in volt per meter, electric field. So this is all are in SI unit. So we know that we have to find out J. We know that J equal to sigma into E. So E by, we can write resistivity, or this can be written E by resistivity is RA by L, right? So it can be written as EL divided by RA. Put all the value. E you know 10, length value you know 10, divided by R value you know 10, into the area value you know. So radius value you know, you can find out. This will be 10 to the power minus 2 pi root over whole square, right? So this will be 110 get cancel out, 10 pi root over square will be pi get cancel out, 10 divided by 10 to the power minus 4, this will be 10 to the power 5, right? 10 to the power 5. In the unit you know that ampere per meter square. So which option will be your correct? So option number 3 will be your correct, right? Option number 3 will be your correct option. Okay, now see another question. Two solid conductors are made up of same material. So same material means what? As soon as same material will come, you will say that resistivity will be same and its density will be same, right? Same material means what? Density will be same, right? And resistivity also same. Have same length, right? So resistivity is same, length also they are telling same, right? One of them has a circular cross section A1, so area is A1, and another one has a other square of section A2, this is A2, right? Same length and same resistance also, so resistance also same, so R also same for both the cases, right? Now they are asking A1 by A2. So if I write down the resistance, R equal to rho L by A, right? So both the length are same, both the resistivity same, I just put A1. Both the resistance will be same, so R equal to rho L by A2. You see here A1 is same as A2, right? Both equation. For one where I am writing this one, for another where I am writing this one, right? So both has the same resistance, same resistivity, same length. So from these two you can say that A1 equal to A2. So A1 divided by A2 is simply 1:1, right? Or you can say that 1:1 simply what? You can, option is given 1, right? So you can write this is 1. So this will be your correct option, right? Clear?